Hello guys, welcome to another video on my channel. Last time we were solving January 2024 paper 3 International Edexcel A levels. The paper code is WPH1301. So today we are going to move on to question 2. If you're looking for question 1, you can check the previous video in the series. Um so question 2 says a student investigated the efficiency of an electric motor using the apparatus shown. So let's first understand what's happening here. The student is trying to investigate efficiency. Efficiency is the energy output over energy input thing, or the power output over power input thing. So useful output power divided by total input power times 100%. This tells you, like, this is the formula of efficiency. You can write it in terms of power or energy. Now it tells you how efficient your device is, like comparing it to the input you've provided to your device, how much output is it giving to you, useful output, because some energy is always wasted. So let's see what over here we have is like what the device we have is an electric motor. We've got a battery and that's connected to an electric motor. Now, what is an electric motor? An electric motor is a device that the input to which is electrical energy, and it converts that electrical energy to mechanical energy. Electrical to mechanical. This is how an electric motor works. So, what is this electric motor doing over here? We've got the battery, we've got a switch. When the switch is closed, current would run. And over here, we have the motor. This over here is a motor. Now, what will this motor do? It will actually rotate this axle over here. This axle that's over here, it will rotate it. When it will rotate it, this rod over here would also start rotating. And as it will rotate, the wire or the rope on it would start to wound. And when it'll wound, the mass will go up. The mass will be lifted. So the purpose of this motor is to lift its mass, right? That is its basic purpose. And what it's taking electrical energy as its input, and the output it's giving us is that it's lifting this mass. When you lift something, you give it height. So it's giving it gravitational potential energy. This is how the setup is working. Okay, so part A is the motor was connected in a circuit, including a battery and a switch. The student connected additional components to determine the power of the motor. Complete the circuit diagram for the circuit the student should use. So if the student wants to measure the power of the motor, okay. Now power, electrical power, equals current times voltage. I times V, current times voltage. So if the student wants to measure power, he needs to do some measurements for current and voltage. So how can the student measure that? So they have provided like some diagram to start with over here. This is a symbol for motor. Let's draw the circuit, like the things that we already know. We know there is a battery in the circuit, and we know there's a switch somewhere over here. This is our switch. Okay. Now see, I'll just connect it below and over here. When we want to measure current through a circuit, we use a device called the ammeter for it. The ammeter must always be connected in series. In a circuit or at a point where it's trying to measure current, it must always be connected in series. So I can place the ammeter over here for that purpose. And then I need to find out the voltage across the motor, the voltage that the motor is receiving from the battery. So voltage is always measured in parallel. Okay, remember that voltage is always measured in parallel, while current is always measured in series. So if voltage is measured in parallel, so the voltmeter will be connected across the motor between 2 points. See, that's what we mean by parallel and series. Parallel means you're connecting it between 2 points. Series means it's just placed at one point in a circuit. So that is how we've connected the ammeter and voltmeter. Now I could place the ammeter here or I could place it here. It doesn't really matter. Okay. It just has to be in series in the circuit. I could also place it like on the other side where I've put the switch. It doesn't matter because the same current would flow here because it's a um, series circuit, right? There are no other branches for current. All right, let's move on. Part B. The student closed the switch in the circuit and the motor lifted the mass from the floor. She used a meter rule to measure the height gained by the 1 kg mass in 10 seconds. Now what's happening? You have um, the student like closed the switch, so there's current going in the circuit. As the current flows in the circuit, the axle over here turns. When the axle turns, the wire on this rod, the rod rotates, so the wire gets wound up on it, and so the mass lifts. Um, and what the student is doing, she's trying to measure the height gained by the 1 kg mass, and she used a meter rule for that. Uh, Describe how she should measure a single value of the height gained as accurately as possible. You should include the use of any additional apparatus needed. Okay, so it's a 4 marks question. Again, I may forget this sometimes, but remember, whenever you're doing a question, you must always look at how many marks are allocated to it, because that gives you an idea of how much to write for that specific question. So if it's a 4 marks question, we need to write 4 points about how to get an accurate value of height. See, the question is not just how to measure height, it's how to measure height as accurately as possible. So let's go back to the diagram and let's imagine that we are trying to measure the height that this mass gains from the floor. It was previously on the floor. When the motor starts working, it lifts up, and we're using a meter rule to measure its height. So the first thing that comes to mind is that if you're using a meter rule, the meter rule must be vertical, okay? If you like make it slightly tilted while taking the measurement, you'll get a wrong measurement. So to make your measurement accurate, the meter rule must be placed here straight. It should be vertical. So one of the things is the meter rule should be vertical. Okay. And the second thing is when taking the measurements, now let's say the mass lifts up to this point, okay? And now over here, you're trying to take the measurement on the meter rule. If you try to look at the meter rule from above or from below or at an angle, like from the sides, because of parallax is an error which you get when you try to measure things from a different angle. Like you try to see a measuring instrument from a different angle, so you see the reading a bit higher or a bit lower than it actually is. So to avoid parallax, what you have to do is you have to directly look at the meter rule at this point, like 90 degrees from it. You should look at like either from the front or like from the front, sorry. From the front, you have to look at it from 90 degrees. Okay. Only then you can make sure that there's no parallax error, like there's no reading error. You're not measuring the reading wrong. So for that, we can say the reading should be taken perpendicularly from the meter rule. Or if I phrase it better, it should be taken by looking perpendicularly at the meter rule. That's the other thing. Now, for the third point, see the meter rule over here. In this diagram, I've just like tried to represent it, but it seems somewhat far away from the mass. Now, if in actual, you put this meter rule far away from the mass and try to measure a reading, there could be an error because the mass is far away, so you might take a wrong value. So you have to put the rule really close to the mass. So maybe you can put it over here, like where it is really close to it. Okay. And when the mass goes up, like it shouldn't restrict the movement of the mass, but it should be close to that. So um, the meter rule should be placed closer to the mass. And the fourth thing, we need 4 points. So yeah, a fourth point is to make sure that the meter rule doesn't move while we're taking the reading. Like we don't tilt it, we don't move it here and there. We can fix it. So we can use a clamp stand to fix the meter rule. And in this way, we can be sure that it doesn't move. So fix the meter rule. Do a clamp stand. You should have to fix it in such a way that it doesn't move during the measurement. So these are 4 points that will provide us with an accurate value of the height gained as accurately as possible. All right, and one more thing we can do is, because they said that you should mention any additional apparatus that is required. So we mentioned the clamp stand, and to ensure that the meter rule is vertical, how can we ensure that? Like, we can use a set square, okay, to make sure that it's placed vertical on the ground. So it should be vertical. Use a set square for that. Okay, I hope that's clear. Let's move on to part two. Part two is explain why repeat measurements are appropriate for this measurement. So why are repeat measurements appropriate? Well, repeat measurements are usually appropriate for every measurement. The reason is because they reduce random error. Okay, the error introduced in the system by our mistakes. They remove that error. Um, so for example, if I'm taking some readings using this meter rule, the first reading that I take, I just take it like the mass is over here. So, but I don't look at the meter rule from here. In, instead, what I do is I look at it like from below or from above. This causes me to take a slightly higher or slightly lower value. Now, if I have that lower value, if I just record one measurement, then I have an inaccurate value. But what if I take, like, if I do it again, maybe the second time I'll do it, I might look from here. So I'll get an accurate value. So what repeated measurements do is they reduce any error in the system. So maybe you took one reading by mistake, like one wrong reading by mistake, but the other one still make sure that like your data is close to each other and there are no anomalies. Like there's no value that's far greater than the rest of the data. So that can spot an outlier. So repeat measurements, what they do is repeat measurements reduce the random error in the system. For example, parallax error. By taking several measurements and calculating their mean. Random error, or we can say random error is reduced. We already said that random error is reduced, or accuracy is increased. because anomalies can be detected in this way. But if you just take one reading and that reading is a bit higher or lower, then you wouldn't know because you just took one reading. All right, I hope that's clear. Let's move on to part C, the last part of this question. It says, explain how the measurements made by the student should be used to determine the efficiency of the motor as it lifts the mass. Right. So, uh, we need to talk about the measurements the student needs to make to find out efficiency. Now, at the start, we discussed the formula of efficiency. We said efficiency equals useful power output over total power input times 100%, right? Um, Now, to find out efficiency, the student needs to know total power input and the useful power output. To figure out what are these things, you need to have an idea of what the system is doing. So the system it's an electric motor. The input energy it's getting is electrical energy. Okay, you've connected it to a battery, so it's getting electrical energy. And the output it's giving you is that it's lifting this mass. It's lifting it. So if it's lifting it, it's giving it height, like it's increasing its height. So it's giving it some gravitational potential energy. Gravitational potential energy is associated with the height of an object. So we know that it's taking in electrical energy. So the total power input would be current times voltage, because that's the input of the battery. The battery is providing voltage and current to the motor. So the total power input should just be current times voltage. And the total power output, we just said that it's giving it gravitational potential energy. So power is work done over time or energy transferred over time, right? Power is energy transferred over time. Over here, the energy that's being transferred is GPE, the gravitational potential energy. And what's the formula of gravitational potential energy? It's equal to mgh, mass times 9.81 times the height over time. So that's like the total power, the useful power output. Useful power output. So now you just substitute it back in the formula. So efficiency equals mgh over T over current times voltage times 100%. You can just like write that uh, or not, it's up to you. So it just gives you mgh over I times V times T times 100%. So these the measurements that the student made, they can help her find out the efficiency because she knows the mass, G the constant, she measured the height, she measured current and voltage, and the time she also measured that. So this is how she can find the efficiency. So I hope the student is this question is clear to you. We can move on to question 3 in the next video. If you have any questions or comments, you can leave them below. And if you need personalized help in physics, please do visit my website, physicsandenglishtutors.online. The link is mentioned below. Do check that out. See you again. Have a good day.